Hi to everyone. In this video, I'm just going to discuss about Warshall algorithm. Warshall algorithm is used to find the shortest path. So what I'm just going to do it here is, here they have given the weighted graph. By using the Warshall's algorithm, I'm just going to find out the shortest path between every pair of vertices. Okay. So first I should calculate as how many vertices are given here. Or here they have given 4 vertices. What are they? R, S, T and U. Okay. So here I am just going to assume V1 is equal to R and V2 is equal to S and V3 is equal to 3 and V4 is equal to U. Okay. So from these things, from this weighted graph, I am just going to derive the weight matrix. Okay. So for deriving the weight matrix, I am going to define one matrix as a W, in which I am just going to consider about the 4 vertices R, S, T and U. Here also R, S, T and U. Okay. So and I should check for the weight for the edges between the vertex R and R. Here the row is R and the column is R, means I should check whether is there any edge connecting the vertex R to R. Okay. So it means self loop, right? So here I am checking for that one. Yes, I am having one edge which is connecting R to R. And the corresponding weightage for this edge is 7. So I am writing 7 here. And then I am checking it for R to S. For the R to S, it's 5. And for R to T, no edge is there. So here I can write 0. And R to U, no edge. I can write it here. And for S to R, I am having 7. 0, 0, 2. Okay. Then 0, 3, 0, 0. And then 4, 0, 1, 0. Okay. So I have filled the weights for every pair of vertices. For example, if you are taking the vertex U and R, U is connected to R and the corresponding weight is 4. I have written this one. So after deriving this weighted matrix, I should derive the matrix as Q0. What is mean by Q0 means, from this weighted matrix only I am going to derive the matrix Q0. For deriving this Q0, I should replace the values which is having 0 here. No, I have to replace all zeros by infinity. For example, here I will have 7, 5 and the rest of the 2 zeros which will be replaced by an infinity. And then 7, infinity, infinity, then 2, then infinity, 3, infinity, infinity, 4, infinity, 1, infinity. Okay. So from this Q0 matrix, what I am just going to do it here means I am just going to derive Q1 matrix. So here I am writing Q1. How I am just going to derive it here means I am just going to select the first column and then first row. So what I am just going to do it here, I am just going to write all the values of the first column and first row as it is. Then To fill these values, I'm just going to take the corresponding row element and column element in the columns and the rows that I have chosen here. So for example, here I'm having 7 and 5. So 7 plus 5, which will be equal to 12. So I should check whether 12 is the minimum number when comparing to infinity or not. But while comparing with the infinity, 12 is the minimum number. So I should write 12 here. I am writing 12 here. The reason for selecting the minimum number here is my task is to select the shortest path, right? That's why I am writing 12 here. Then for filling this element 7 plus infinity, when I am adding any element to the infinity, I will get infinity only. So infinity is compared with infinity means I will get infinity only. Then 7 plus infinity, infinity. When comparing infinity with 2, 2 is the minimum one. So I can write 2 here. And then here infinity. So infinity plus 5. Infinity will be compared with 3. 3 is the minimum one. Then infinity plus infinity. Here also infinity. So simply we can fill infinity here. Then infinity. Here also infinity. We can write infinity here. Okay. Then for filling this one, I'm sorry, here I should write 4 here. Okay. So here what should I do it here is 4 plus 5 9, right? So 9 will be compared with the infinity. 9 is the minimum number, so I can write 9 here. Then 4 plus infinity. So 4 plus infinity, we will get infinity. Infinity will be compared with 1. So 1 is the minimum number. We can write 1 here. Then 4 plus infinity. Here also infinity. So we can put infinity here. Okay, so we have derived the Q1 matrix. Then I have to derive Q2 matrix from the Q1 matrix. Okay. So what I am just going to do it here means, in the Q0 matrix, I have chosen the first row and first column. No. Here I am just going to select second column and second row. So Q2 matrix, which will be derived from Q1. I'm just going to write it here. Check the value. 7 plus 5, 12. So which one is the minimum? 7 is the minimum. So we can write it here. And these values you can write it as it is. So 5, 12, 3, 9. And here also 7, infinity 2. Okay, so in order to fill the value for this one, here you can take the value 5 and infinity. So here also infinity, we can write infinity. Next 5 plus 2 7, which will be compared with the infinity. 7 is the minimum number, we can write it here. Okay, so then what should I do it here? 7 plus 3, 10. 10 will be compared with infinity. 10 is the minimum number, so we can write 10 here. Next, to fill this place, 3 plus infinity. Here also infinity, so we can write infinity here. Then 3 plus 2, 5. 5 will be compared with infinity. 5 is the minimum number, we can write 5 here. Then for filling this place, you have to take these two numbers. 9 plus 7, you will get 16, which will be compared with 4. 4 is the minimum number, so we can write 4 here. And for filling this place, you can take this one. 9 will be compared with 9 and infinity will be added. We will get infinity. So infinity will be compared with 1. So we will get 1 here. So then 9 will be added with 2. We will get 11. 11 will be compared with infinity. So the minimum number is 11 only. So we can write 11 here. Okay. So from this Q2 matrix, I am going to derive Q3 matrix. So while deriving Q3 matrix, I am just going to take the third column and the third row. Okay. So here what I am just going to do it here means since I have taken the third row and third column, the same process have to be repeated again. So you can fill these values infinity, infinity, 1 and 10, 3, 5. Okay. Okay, you just see here, for filling this place, 10 will be added with the infinity. So infinity will be compared with the 7. 7 is the minimum number, so you can write 7 here. Then 3 will be added with the infinity. So we will get infinity. So infinity will be compared with the 5. So 5 is the minimum number. You can write 5 here. Then you can, for filling the place here, for filling this place, you can check this one. 5 and infinity will be added. So we will get infinity. Infinity will be compared with the 7. So it means 7 is the minimum number. So we can write 7 here. And then here 10 will be added with infinity. Whatever the number that you are adding with infinity, we will get infinity only, right? So that's why 7 and infinity will be compared. The minimum one is 7. You can write it here. Then 3 plus infinity. So we will get infinity. So infinity will be compared with the 12. In such a case, 12 is the minimum one. You can write it here. Then 5 plus infinity, infinity. Infinity will be compared with the 2. 2 is the minimum one. You can write 2 here. Then 10 plus 1, 11, right? So 11 will be compared with the 4. 4 is the minimum one. We can write 4 here. Then 3 plus actually what we are going to do it here, 3 plus 1 we will get 4, right? So 4 will be compared with the 9. So the minimum one is 4. So you can write it here. Then 1 plus 5, 6. 6 will be compared with 11. So the minimum one is 6. Okay. So next I am going to derive Q4. So for deriving Q4, I am just going to take the fourth column and the fourth row. Fourth column and the fourth row. So here I am writing 7, 2, 5, 6, 4, 4, 1. Okay. So and the rest of the places I should fill it. Okay. So 7 plus 4 plus 7, I will get 11. 11 will be compared with 7. Of course 7 is the minimum number, so we can write 7 here. Then 4 plus 7, again we will get 11. 11 will be compared with 5, so 5 is the minimum number, we can write it here. Then 1 plus 7, we will get 8. 8 will be compared with infinity, so 8 is the minimum number. And then 4 plus 2, 6. 6 will be compared with 7, so 6 is the minimum number, so we can write 6 here. Then 4 plus 2, 6. 6 will be compared with the 12. 6 is a minimum number. So we must write 6 here. Then 1 plus 2 which is equal to 3. 3 will be compared with infinity. So 3 is a minimum number. We have to write 3 here. So then 4 plus 5 we will get 9. 9 will be compared with the 10. So 9 is the minimum number. We have to write it here. Then 4 plus 5 it's 9. Again 9 will be compared with 3. 3 is the minimum number. We can write it here. And then we can consider this one. 1 plus 5, 6. 6 will be compared with the infinity. Of course 6 is the minimum number. We can write it here. Okay. So after deriving the matrix Q4, there is no necessity to derive one more matrix as Q5. Reason here is, since we have processed till the 4th row and 4th column, there is no necessity. And one more thing, here we are just having only 4 vertices. So up to Q4 you can stop it and you can conclude this is the shortest path between every pair of vertices. For example, you know very well, this is R, S and then T, U. Here also R, S, T and U, right? So if you are covering the vertex here, means just for an example I am writing, if you are taking it between the R and the path for the reaching the vertex R from the vertex R, the distance is 7 mentioned here. So you are having the edge which is connecting the vertex R to R. So here you can write R to R. Okay, and then you can write R is connected to S. Okay, shall I write it here? Okay, I am just writing it here. I hope it's visible for you. So here I am writing R to R. And for 5, you are having R to S. You are having the direct edge. So you can write RS. And for the 8, R to T, you are having 8. Weightage is 8. So what's that one from R to T? Right? So it means... how can you get 8 here? Means from R to T. Yes, you can take this one from R to S. You are having this one. From S to U, you are having 2. And from U to T, you are having 1. So 5 plus 2 plus 1, you are getting 8. Right? So you can write the path as R to S to U to T. And then for the path for 7 is R to U, the weightage is 7. So from R to U, weightage is 7 means you can consider this one. Here you are having 5, 2 and the arrow mark is pointed towards S and from S to U. Right? So here you can write the path as R from the vertex R to S, S to U. Right? So then for this place, you know very well, we are having 6. So S to R. From S to R, you are having this one edge, and next one is from this one S to U, U to R. So here you can write S to U, U to R. Okay. And then for this one, S to S. For S to S, no loop here, but we can say from S to S, we can write like this one, S to U, U to T, T to S, right? So here we can write S to U and then U to T, T to S. Okay, so and then for this one it's 3, S to T is 3. Check that one. From S to T is 3 means SU from U to T. S, so you can write SUT. And same way you can write SU here. And here TSU or right. And then here TS, here TSU to team, TSU and U or UTS, and for here the UT, and for here UTSU. Okay, so it just defines the shortest path between every pair of vertices. This methodology is called as Warshall algorithm. Actually what we have calculated here is we have traced the shortest path using Warshall algorithm. So we may conclude as Warshall algorithm is used to trace the shortest path between all pairs of vertices. How we are going to trace it means by calculating the minimum of the two things. So what are the things? We are just going to sum of these values and it will be compared with the existing value here. Then we are going to calculate it. We may say it in another words as QK of, I will just write it here. Can write it as QK of IJ is equal to min of QK minus 1 I comma J comma QK minus 1 I comma K plus QK minus 1 K comma J. That's all. So this is the equations. By using these equations only we have solved these things. Okay. So I hope every one of you got a clear idea about how to trace the shortest path using Warshall algorithms. In case if you are having any doubt, kindly post your queries. Thank you.